Hello students. So this is grade 10 lesson 2 classes. So last time we have to learn about for the chapter 3 of the grade 10s, which is the electrochemistry. So simply we have seen that the electrochemistry means it is a field of chemistry that dealing with the relationship between electrical and chemical energies, so that this change that occur in the electrochemical cells. That's why we have two types of electrochemical cells. We're saying that's electrolytic and voltaic cell. And also we have seen the electrolytic conductivity. So we have two types of electrolytic conductivity, the one metallic and electrolytic conductivities. And also that finally we have seen that the uses of the electrochemistry in the industries. So in the industries, electrochemistry that are used for the production of compounds and also the metal and non-metal for the purification of metal and so on. The electrochemistry used we have seen in the last terms. In this lesson we have seen the chapter 4 of these texts. So chemistry in the industry and the environmental pollution. So this chapter that contains 5 sessions, which are the introduction part and the natural resource and the industries and the production of some important metal and non-metal and the chemical industries. Finally, we have seen that the environmental pollutions. So let's start from the introduction parts. So to starting, what is the chemical industries? Just simply, chemical industries means they are the institutions involved in the production of chemical products. So these industries, they have their general characteristics. Let's be, they are available or used naturally available raw materials to producing a desirable products. And also that these characteristics, they involve in the chemical reaction transforming the raw materials into finished and semi-finished products. And finally, the characteristics of these chemical industries are they are consumed relatively large quantity amount of energies during in the manufacturing processes. And finally, use safe operation methods their manufacturing processes, so that these are the general characteristics of the chemical industries. So these chemical industries using that naturally available raw materials means these natural resources that has to use to be in this chemical industry. So this natural resources has to be classified into parts. The one, renewable resources, and also that non-renewable resources. The renewable resources means they are replaced or replenished by natural process. So we can take that examples for this renewables are the plant and also that's the animals and so on are simply we can replace or replenish from this. And the non-renewable resource means the resource it has to be found that in a fixed amount of in the nature and we cannot be just replenished, which means completely used up. Such examples of non-renewables resources are the natural gas and the coals. And also that the other station of in this lesson, the production of some important metal and non-metals. Firstly, we have seen that the important production of important metals in the industries. All of the metals just they have to be found that in the form of a compounds, but in this production of some important metals we have seen that important metals are the aluminium, the iron, the coppers. Of these 3 elements we have seen that their occurrences and how to extract from their compounds, and also that what are their physical properties, and also that in which substance they can be reacted, which is what are their chemical properties. Finally, what are the uses of these important metals. Firstly, we have seen that this aluminium Aluminium is the most abundant metal in the third most plentiful elements after oxygen and silicon in the Earth's crust, and also that it is the second most important metal after iron in terms of the consumptions. So that this aluminium, it doesn't occur as a free metal in nature, which means it has to be found that in the form of a compounds. The principal source of this aluminium is a bauxite, but aluminium it has to be found as any other compounds which are, let's be orthoclase, cryolites, and also the corundums and the others, the ores of the aluminium. But aluminium industrially that are extracted by the principal ore, which is a bauxite. So the process, we call it as the Hall process. The Hall process means the industrial production of the aluminium to take the process, and also that the physical properties of this aluminium, just simply it is a soft silvery and a white metal having a density up to 2.7 grams per centimeter cube, and it melts at this degree centigrade, which is 66 degrees centigrade, and also that this aluminium, it can be shaped into wires, and it can be rolled, it can be pressed, or it can be cast into different shapes. And also that the physical properties of this aluminium is it's a good conductor and heat and electricity, which means aluminium is, it can be conduct heat, and also that it can be conduct the electricities. So this aluminium, it has a chemical properties, which means aluminium, it can be reactive with the metals, which means aluminium is a reactive metal. And also that even though its reaction are not vigorously in the comparison with those of a sodium, which means it is not more reactive. Even if it is a metal, it is not more or very active than that of the sodium, potassium, and the calcium, which means the reactivity less than that of these metals. And the other metals of the group 1 and the group 2, which means the group 1 and the group 2 elements are the more active metals. Simply, we call it that. And this aluminium, it can be reacted with the oxygens, and also that aluminium react with oxygen, just simply it forms the aluminium oxides, and also that this aluminium, it can be react with a dilute acids when it forms a salts of aluminium, and there is a liberating of hydrogens. Let's say aluminium react with a sulfuric acid, and the product is aluminium sulfate, and also that this aluminium that react with hydrochloric, so it produces chlorides of aluminium, which means aluminium chloride, and there is a liberating of the hydrogens. And also this aluminium, it has many uses. From this uses of this aluminium, aluminium is a light weight, and also thus it can resist a corrosion. So it is used to make light alloys, and like a duralumin. A duralumin means it is a mixture of the aluminium, copper, and magnesium. So thus alloys of aluminium are extensively used in the transport industries to make, because of its lightness, in the transport industries to make aircrafts, ships, and the cars. Just simply that are made by the alloys of the aluminium, and also that this aluminium used in the manufacture of household cooks, which means in the household cook means utilities, due to this high thermal of the conductivity and the resisting of the corrosions. So it is also used to make door and window frames and roofing of the buildings as packaging material in the food industries, and for the electrical transmission, the wires. So that the next important metals are these irons, like that of the aluminium. this iron has its occurrences, and also that it has an extraction method, and also like that of the aluminium, it has its own physical properties, and also that its chemical properties finally uses. So starting with its occurrence, this aluminium is the second most abundant next to the aluminium in the Earth's crusts, but in terms of consumption it comes to the first and the fourth most abundant element. So this iron, it cannot be found as a free in nature, as a free metal in nature, which means it has to be found that in the form of a compounds, in different compounds, like that. It has to be found that in the form of oxide, in the form of carbonates, and also that in the form of sulfides. Let's say in the form of oxide, it can be found as hematite, which means iron oxides, and limonite, hydrated iron oxide, and magnetite, and also that siderite. Siderite is in the form of the oxides, this iron to be found or to be occurs. And it is also found in the form of iron pyrite, commonly we call it that a false gold, and is extracted that are carried on in the blast furnace. So the iron, it can be extracted industrially, the blast furnace. The blast furnace is a material to be extracted, the irons. So this blast furnace mainly it contain different materials. These materials are the firstly, there must be the ore of the irons, which means the iron to be extracted, and also that we need that a coke, and also the limestone and the hot air that are needed to in the blast furnace. So that how could they make the reaction in the blast furnaces? Just simply the overall reaction in the blast furnace, as we look this, firstly there is an oxidation of coke into carbon dioxide, which means carbon that are react with oxygen to producing a carbon dioxide, and also that the heat. And after this carbon dioxide that are reduces to carbon monoxide. When the carbon dioxide again it reacts with a coke, which means a carbon, to producing a carbon monoxide. So that this carbon monoxide that reacts the ores of the irons to make the iron oxides, which means for looking at this reaction, this carbon monoxide that react with those of the irons, like that the iron oxides react with the carbon monoxide. And the next step, which means the decomposition of the limestone by heating in the blast furnace, serves as flux to remove the impurities. So that's the purpose of this calcium carbonate that are used to in the blast furnace, used to remove the impurities or the unwanted material for in the extraction of the irons, so that this calcium carbonate that are decomposes into calcium oxide and carbon dioxide, and the reaction of calcium oxide with the impurities like silica to form a calcium silicate, which is called a glass-like material. So this calcium, the decomposed calcium oxide, react with the silica to form a calcium silicate. So this calcium silicate, a glass-like material, we call that a slags. So that in the blast furnace, one of the products, the impurities, we call it that a slag. In the other side, the parts of or the extracted iron to be obtained, so that this slag sometimes used to in the manufacturing or in the industry of a cement, and also that the iron that are obtained directly from the blast furnace, we call it that a pig irons. So it is impure and it contains about the other impurities, like that 2% of silicon, up to 1% of phosphorus, and also that manganese, and the traces of the sulfurs. So this impurity to make this pig iron is a brittle. So when pig iron again remelted and scrap and cast into the molds, it comes to forms of a cast irons. So that to forming that a cast iron, again we remelted these pig irons. And also thus the other types of the iron, we call that a wrought iron. Wrought iron is the purest form of the iron in a commercial. So it is manufactured by heating of impure iron with hematite and limestone in the furnace. So this increasing the impurity of the iron to be up to 99.5%. So the impurity or purity that takes in 99.5%, the iron, we call it that, a wrought irons. So wrought iron is a tough and malleable, ductile form of the irons. So that's when we see that the physical properties of the irons, just simply iron is a gray and luster and malleable and ductile metal, and also that like that of the aluminium, iron is a good conductor of heat and electricity, which means it can conduct the electricity and also that it can conduct the heat. And it had a high melting point, so it melts 1580 degrees centigrade, and a high density it has, which is 7.87 gram per centimeter cube is dense. So it is a ferromagnetic metal, which means permanently it is magnetized. So that this is the properties of these irons. So that iron, it can be undergoes in different or it can be reacted with different substances, or it undergoes in different chemical reactions. So that this chemical reaction, just simply iron is, just simply we know that it is a reactive metal, so its reactivity is very slow. Again, we are not comparing the reactivity of the iron and also the aluminium with the group 1 and the group 2 elements, because the group 1 and the group 2 elements they are metals, and also that they are a very reactive metals. But we're saying that iron is a metal, just we are not comparing the reactivity to the group 1 and the group 2s, just simply. And iron, it rests in the presence of air and moist to form hydrated irons oxide, which means iron, when it reacts with the oxygen in the presence of a moist air, it forms a rust, which is hydrated iron oxide. So iron, it can be reacted with a diluted acid like that, chlorines and sulfuric, to form a salts of the irons, and there is a liberating of the hydrogen gas. As you look, that's the reaction of the iron with the acids like that, hydrochloric, to form salts of iron, which is called iron chloride, and there is a liberating of the hydrogen gases. And also thus iron that reacts with sulfuric acids, again it forms a salts of the iron, which is iron sulfate, and there is a liberating of the hydrogen gases. And also that thus are some chemical processes of the iron. Then finally, just we have seen that the uses of this iron. So that iron is mostly widely used in the metal and take first position in terms of the consumptions in the worldwide, because we have to use in that more of the irons in the manufacturing industries, I mean in the building, and also that in the bridge, which means it used to as a structural metal in the construction of buildings and bridges. So that in the form of big iron, which means we have seen that in the previous, there are just the irons, pig irons, wrought iron, and the cast irons. So that the pig irons, the pig irons that are used to make domestic boilers, hot water radiators, and railings, water pipe, casting, and moldings. As wrought iron, again it used to making like nails, sheets, and horseshoes, and ornamental gates, door knockers, and farm machineries that are made by the types of the iron, which is a wrought iron. And the iron is also used in the manufacturing of the alloys. The alloys are a carbon steel and also that the alloy steel. In these alloys, the carbon steel to be classified into three parts based on they contain the amount of the carbons, like that. When you see that, the parts of the carbon steel, the high carbon content, high carbon steels, it contains the amount of the carbon up to 1.5% of the carbon that contains the high amounts of the carbon steels. So that's why these alloys of the iron classified in the carbon steel and also that in the alloy steel, so that you can refer more the carbon steel and the alloy steels in your own. So that these are the properties, the uses of the iron. And the next important metal is the coppers. So most important metals within that in the above the aluminium, the iron, and the other important metal is a copper. So that's like that of the aluminium and also that the irons. We have seen that this copper, its occurrences and how it extracts from its ore, and also that it's a physical property and it's a chemical, finally how it used in our daily lives. So that this copper is occasionally found as a native copper. However, it's found mainly in the compounds, in the form of a compound such as sulfides, oxides, and carbonates. The most important sulfides are chalcopyrite, which means the copper that's to be found in the copper iron sulfides, and chalcosides and covilites and boronites are the ores of the coppers. So the principal oxides are copperite. Copperite is a copper oxide, and also that telluride, again is a copper oxide. These two are the principal oxides of the coppers. And the carbonate or the copper that is to be found as in the form of a carbonate forming, it exists as malachite, which means hydrated a copper carbonates. So that's when you see that the physical properties of this copper, just simply copper is a soft, ductile, malleable, and it has a reddish brown metal with a density 8.96 gram per centimeter cube, and it is the second to silver in the electrical conductivity, which means in the electrical conductivity, firstly we have to use that this silver, next to silvers, just more we have using that this copper. So the copper, it melts 106 degrees centigrade, and it can be boiled at 2310 degrees centigrade. Thus are the physical properties of these coppers. When you see that the chemical properties of this copper, like that of the other metal, copper is less reactive metal when you're comparing that the aluminum and the irons. That's why it has to be found as in the native state. Although it is not very reactive, it under in the following reactions, which means the copper that reactive with oxygen, specifically the powders, so to producing the copper oxides. And again, copper does not react with a dilute acid like hydrochloric and sulfuric, but it cannot displace. When it reacts with in a diluted or in a concentrated acids, it doesn't replace the hydrogen atoms. Most of the metals, when they react with the acids, they replaces the hydrogen atom. In case of the copper, it doesn't replace the hydrogen from the acids. So that its reactive is it can be oxidized by oxidizing acids such as a dilute and concentrated nitric acids and hot concentrated sulfuric acids. So it produces this compound is copper dinitrate and nitrogen monoxide and the waters in the first, which means a diluted sulfuric acid, and also that it can be reacted with a concentrated nitric acid and also that a hot and concentrated sulfuric acids. So when you see that the uses of the copper is due to the manufacture of the alloys, which is, let's see examples. Bronze is an alloy. It is a mixture of copper and tin. So these bronze that are used to make coins, medal, bells, machinery parts that are made by the bronzes. And the other alloys are the brasses. The brass is a mixture of the copper and a zinc, and it used for the hardware tops, terminals and pipes. And copper is widely used in the electrical industries in the form of electric wire and cables. So copper compounds such as copper chloride, copper carbonate and copper hydroxide and so on that are used to like pesticides. So thus are the important metals within that the aluminium, iron and copper, and also the other production of some important non-metals. So in the production of some important non-metals, just important non-metals like that, the nitrogen and the phosphorus and also that's the oxygen and the sulfur and the chlorines are mostly used up in our daily life. That's why selectively we have seen that how they produces in the industries this important non-metals. When you start with the nitrogens, so again we have seen that its occurrence and how to produce in the industries. So nitrogen occurs in nature is in the elemental forms, which means it also exists in the form of a compounds. This nitrogen in the elemental state, it exists as a diatomic molecule in the atmospheric air. So the atmospheric air, it consists of about 18% by volume of the nitrogens. So that in the form of a compound, this nitrogen, it exists as a sodium nitrate, which is called Chile saltpeter, and also that a potassium nitrate, which is called a saltpeter. So in the form of a compound, this nitrogen that has to be found in this compound, and also is found in the DNA molecules and the proteins of all living things. So thus, when you see that its physical properties, the nitrogen is a colorless, odorless and a tasteless gases. So it's inert under ordinary condition, and that is why it is found in atmospheric air as a diatomic molecule. So the inertness of the nitrogen at low temperature, that are directly related with the strength of its bonds. That's why the triple bond between the molecule of the nitrogen, they need that high amount of energy to break those bonds. So this is because of its inertness. So that let's see the chemical properties of the nitrogen. Just widely, it can be reacted with a group 1 and a group 2 elements as well as oxygen in high temperatures. Like the group 1 and the group 2 elements, when you see that lithium, calcium, magnesium, these are the metals. When they react with the nitrogen, they form nitrides like lithium nitride, calcium nitride, magnesium nitrides. So this nitrogen also, it can be reacted with oxygen. It forms oxides of nitrogens like dinitrogen oxide and nitrogen oxides. And nitrogen that are directly react with hydrogen in the Haber process to form the ammonia. but this ammonia is very important for the production of in the industry, so that this nitrogen that's reacted with the hydrogen to produce the ammonia. So that these are the chemical properties of the nitrogens. So that this is all about the today's lesson. So what we learned is in these lessons, just simply we have seen that the chemical industries, so these chemical industries, they have their own characteristics. So we have seen that what are the characteristics of these chemical industries, and then important including that the natural resources to classify into parts renewable and non-renewables, and also thus the production of some important metal and metals. When you see that the production of metals, we have seen aluminium, iron and copper, their occurrences, how they extract from their ores, and what are their physical properties, and also that what are the chemical properties, and finally what are their uses in our daily lives. And finally we have seen that the one of the important non-metal, which is the nitrogen, like that of the metal, we have seen that its occurrences and how it extracts from its ore, and also that what are the physical properties of this nitrogen, and also that how it uses in our daily life. So that this is all about the today lessons. Just see you next.